Dear all, welcome back. This video we will cover type of relations. So let's talk about void relation. So this is basically if you have a set A which has no relation or empty relation with its own elements. This is called a void relation. So basically we'll say if there's an A cross A or A Cartesian product A and there's a relation which has phi. There is no relation. It's also a subset of A cross A. So that's a void relation. Next we talk about universal relation of set A. So basically if every element of A is related to every other element of A, right? Each element of A is related to all other element of A. Essentially, actually it means A cross A, right? All Cartesian product. So say A is a set with 1, 2 and 3, then universal relation is basically 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3 and 3 comma 1, 3 comma 2, 3 comma 3. So all possible relation or every possible relation. Okay? It is a subset. In this case, mainly equal. This is called a universal relation of set A. Next, we talk about identity relation on a given set A. Right? So if A equals to AB, C, then identity relation is basically A cross A, BB, and CC. Right? That is, every element of A has its same relationship with itself. Every element of A is related to itself. That is what we call as an identity relation. So let's take another example. there is a set A with three values, and there is a relation R which says 1, 1, 2, 2, 2, 1, and 3, 3. Now it has 1, 1, it has 2, 2, it has 3, 3. So it has all the elements of A which is related to itself. Is this identity relationship? And the answer is no, because it also has an element of 2, 1, which is not an IR. Does not belongs to IR. So hence, in an identity relationship, it's only the relationship of its element with itself. Similarly, if R was 1, 1 and 2, 2, this is again not equals to IR, as it is missing. Three, 3. Right? So every element has to have its relationship with itself to be an identity relation. Right? You cannot have an extra element or extra relationship other than the relation to itself. Also, you cannot have something missing. In this case, 3, 3 was missing. This is called identity relation. Similar to identity, there is another relationship which we call reflexive. This is a reflexive relation. Here again, it's same as identity, where if there's A belongs to A, then A comma A should belongs to R. Right? That is, every element of A should have the relationship with itself. So like if A equals to 1, 2, and 3, then reflexive element would be 1, 1, 2, 2, 3, 3, with one difference. It can also have relationship which is different. Right? However, the minimum requirement is at least this 3 relationship should always be there. So hence we can say that identity relationship that we talked about is basically a subset of reflexive. Identity is a subset of reflexive. So basically, if any of these are missing, then it's not a reflective relationship. So if I have an R which says 1, 2, 1, 1, 3, 3, 3, 2, this is not reflexive as two, 2 is not belongs to R in this case, right? So if 2, 2 was also part of R, then it would have been reflexive relationship. Good. So you understood what is the reflexive, what is identity, and what is the relationship between identity and the reflexive relationship. So another type of relationship is symmetric relationship. That is, if there are elements such that A belongs to A and B belongs to A, if A and B belongs to R, then B comma A should also belongs to R. Then we call this a symmetric relationship. Let's take an example. Say parallel lines. If there's a line L1 which is parallel to line L2, then L1 is related to L2. But if this is the case, then we also know that L2 is parallel to L1. Right? So L2, L1 will also be in the relationship of parallel lines. So this is called a symmetric relationship. So basically, if you have set A which has two elements, then if there is a relation between 1 comma 2, there has to be a relation between 2 comma 1. So both these relationships should be part of R, and this is what we call a symmetric. Another example could be perpendicular lines. Right? If L1 and L2 are perpendicular, then L2 and L1 are also perpendicular. So there is a relation which talks about perpendicular line, then both L1 L2 and L2 L1 would be part of that relation. So this is what we call a symmetric relationship. Right? Let's talk about the last relationship type, which is a transitive relations. So what does that mean? If there is A comma B which belongs to R and B comma C which belongs to R, then C comma A needs to belongs to R, where A, B and C belongs to a set. Right? So if A and B is belonging to R, B and C belongs to a relation, then C and A has to be part of that relationship. And this is what we call it as a transitive relationships. So we can say in the same example where relationships is parallel lines. So there's L1 and L2 which is parallel, and then there's L2 and L3 which are parallel lines. Then we know that L3 and L1 will be parallel. Right? So if L1 is parallel to L2 and L2 is parallel to L3, then L3 would be parallel to L1. This is what we call transitive relationships. Next video, let's do some quiz. on these relationships.